Hey, this is Mr. Ward, and I'm doing a video key for Geometry Exit Ticket 19.1. Please do this, and please hit submit when you get to the end of it, of course. Okay, so please let me know what you're understanding now about strategies for solving proofs. Hopefully you are in chapter 4 by now. If you're not, please do some homework to get there. So number 4A, what is the conclusion that needs to be proven here? So this is stated in an unusual way from what you've been dealing with. It says the bisector of the vertex angle of an isosceles angle is perpendicular to the base. Okay, so the vertex angle has been bisected. Well, that doesn't seem to be the conclusion. The bisector of the vertex angle is perpendicular to the base. The triangle is isosceles. So triangle being isosceles is just stated. It is an isosceles triangle. That's what we're dealing with. That's a given. Okay. The vertex angle being bisected is stated. So this is a thing called the bisector. It probably would be useful for you to draw this, of course. What we're trying to prove is that this bisector is perpendicular to the base. So that's the conclusion that we're trying to deal with. So we would have our isosceles triangle. Okay, we have been given that it's isosceles and there's a base. We know that this is an angle bisector, which means that this angle and this angle are congruent. Okay, so those are things we've been given. What we're wondering about is this perpendicular to the base? And that's what you need to prove. This is the question mark. Okay, is that a right angle? Does that make a right angle with the base? Does that angle bisector of vertex angle bisector, does that make a perpendicular segment to the base? That is what you're trying to figure out. And so that's the conclusion. Okay, so that's right. The thing you need to prove is the bisector of the vertex angle is perpendicular to the base. Now, what are things you can immediately assume from that statement below? Pick all 5 that apply. Okay, so there's some things that we can assume. We can assume, no, we can't assume it's equilateral. We can assume it's isosceles because that's one of the statements. The vertex angle of the triangle is divided into non-congruent angles. Well, it's an angle bisector, so no. So that means it is divided into congruent angles. The bisector is perpendicular to the base. That's the conclusion we're trying to prove. We can't assume that yet. The bisector is congruent to itself. Absolutely. That's an easy grab. The base angles are non-congruent. Well, it's isosceles, so the base angles are actually congruent. Okay. The 2 sides that are not the base are non-congruent. The 2 sides that are not the base are congruent. Well, it's isosceles. That's the definition of an isosceles. The base is divided into congruent segments by the angle bisector. Well, no, we can't conclude that yet. We're going to have to do some proofy stuff. It won't be hard to prove that that's true, but there are some things we have to get to first. So we can definitely say that these angles are congruent because it's an isosceles triangle. And we can say that this angle bisector is congruent to itself by reflexive property. So you can prove easily with angle side angle or side angle side that these 2 triangles will be congruent, which will lead us to these angles being congruent, and that will lead us to Theorem 21, which get us that they are perpendicular. This angle bisector is perpendicular to the base because adjacent congruent angles are 90 degrees. They produce a perpendicular. So there you go. So for this question, oh, that's interesting. I have a bit of a typo in here. So you'll need Theorem 21 for the next question, but I didn't put a next question in, so don't worry about that. I will remove that from this exit ticket. So that's really all you needed, was these questions. All right, I hope that was helpful, and it was helpful to me to find this error in what I put in here. I hope you had a good class.